Hi girls, I'd like to show you how to solve for an inverse function algebraically. If you remember, the 4 steps we talked about in class were to first replace f of x with y, second to switch the x and the y variables, and then to solve for y as a function of x. Once you've isolated the y variable, you can rewrite it as f inverse of x. Okay, let's look at an example. Okay. So first example, we're given f of x equals 5x minus 7. First step, to rewrite f of x as y. Second step, switch the position of the x variable and the y variable, giving us x equals 5y minus 7. Now we want to isolate the y value here. So add 7 to both sides. X plus 7 equals 5y. Divide both sides by 5. And we end up with x plus 7 over 5 equals y. Since we know y is a function of x, in fact it's the inverse function of the original f of x, we can rewrite this y value as f inverse of x. Great. Okay, another example using the same steps is the following. For B, I want you to again solve for the inverse function of f of x equals 3 minus 0.5x. Okay. Rewrite as y equals 3 minus 0.5x. Switch the x and the y. And now we have x equals 3 minus 0.5y, and we need to solve this for y. Subtract 3 from both sides. So x minus 3 equals negative 0.5y. And to do the inverse operation to negative 0.5 times y, we're going to multiply both sides by negative 2. Distributing this through, we end up with negative 2x plus 6 equals y. And again, this y represents the inverse function, so we can rewrite that as f inverse of x. Okay, let's look at one more. Now, if you'd like to try this one on your own before checking your answers, why don't you press pause after I write the function and give yourself a chance to see if you can do it by yourself. So the function is f of x equals 1/2 times 3 minus 3x. If you want to try this on your own, go ahead and pause the video now. Okay, welcome back. The solution to this problem is found by first switching f of x with y, and switching y and x. Oops, sorry. So we have x equals 1/2 times 3 minus 3x. Now you have to, oh sorry, what should I have said? 3 minus 3y. Okay, now you have to isolate the y variable by undoing the function on the right. So we're going to go through the opposite order of the orders of operations. So first thing I'm going to do is multiply both sides by 2 to get rid of that 1/2. So we get 2x equals 3 minus 3y. Subtract both sides by 3. 2x minus 3 equals negative 3y. And then divide both sides by negative 3. So we get negative 2/3 x plus 1 equals y. You may have chosen to rewrite that instead as negative 2x minus 3, all divided by negative 3, and that's fine. Either way, you end up with a function for y in terms of x. We know that this represents the inverse function, So let's rewrite that as f inverse of x. Now just to confirm that this is in fact the inverse function, let's check with some points. So let's choose for the original function x equals 1. See, for the original f of 1 would then be 1/2 times 3 minus 3 times 1, which is 1/2 times 0, which is 0. So we want to check that the inverse function does in fact switch the x's and the y's, so that when I plug in 0 for the inverse function, I would get out 1. So it's f of 0 equal to 1. I'm sorry, f inverse of 0 equal to 1. Okay, so again, we're taking the output from the original and putting it into the inverse, and we're checking that we get the input from the original as the output of the inverse. So let's see, what is f inverse of 0? Scroll back up to see what f inverse was. So that's negative 2/3 times x plus 1. So we have negative 2/3 times 0 plus 1, which is 0 plus 1, or just 1. So it turns out when we plugged 0 into our inverse function, we did in fact get out 1, which was the original input, when 0 is the output. So this is in fact the inverse function for f of x, and our work was correct. So I hope this helped. Feel free to email me or come to Math Lab if you have any questions on this stuff, and we can go over a few more examples during class tomorrow. All right, thank you.